Hi everyone, this is the presentation video of Applied Lateral Language Processing Project. Our group members are Cui Jinkai, He Xiying, and Tan Ruoshui. I will give a brief introduction of our NLP model. The growing number of electrical devices turns people's action into digital. With settlement included in this electronic document, settlement classification becomes a rapidly developing field of study that seeks to figure out the emotional information inside them. In this project, we try to use LSTM to classify movie reviews into two categories by dropping out stopworks and applying tokenization. The binary classification model has an accuracy of more than 85%. We use LSTM as the core of our learning model. Long-short-term memory is a type of RNN architecture. One of the main components of RSTM is called RSTM block. A RSTM block has an input gate, forget gate, and output gate. The other component is called cell state. The cell state lives throughout the LSTM network as a register to indicate long-term results. We didn't do transfer learning in this project, but our build-up model can be part of component in the future transfer learning process. There are 4 types of transfer learning. We'll focus on the deep learning method. Deep learning-based method is try to transfer the language data into data-independent representation factors. Then use CNN to do the extraction and classification. If any future process happens, is deep learning-based transfer learning. Now, let's welcome Ruoshui to talk about the detailed steps of implementation.
Firstly, to read the IMD dataset document, we use this function. The dataset has 2 columns. One is the movie review, while the other one is the category of it, which is positive or negative. The content of the IMD dataset is here. Next, in order to increase the final model accuracy, we filter out some spots first before we do the embedding and training. In the original data, except for movie reviews, some additional information are also included, which may bring negative effects to the training process. Therefore, we are going to filter out all this information. The reviews categories are set to negative or positive. To make the 2 categories be computer-friendly, we include positive as 1 and negative as 0. The data after filtering are placed here. In this part, we want to split the dataset into 2 parts. One is training set and the other is a testing set. By calling this function and setting the test size as 0.2, the original dataset now becomes 80% training dataset and 20% testing data. The more important is by applying this function, both categories of data place uniformly and good for increasing the model accuracy. The 2 splendid sets are listed as follows. As we can see, there are 40,000 movie results in the training set and 10,000 reviews in the testing set. The data categories are out of order. We design a function called getMaxLength to calculate the mean of all the reviews lengths and the reference embedding sequence length to make sure that the final process reviews are equally splendid. The tokenizer in TensorFlow is used to convert the text information of commands into digital information for subsequent neural network analysis. The vocabulary can be automatically indexed by using fit-on-text. Then we will fill or intercept the command information according to the average length specified by us through past sequences to make the data length the same. Through processing, we can see that the original test information in the commands of training set and testing set are placed by numbers and they have been adjusted to the same length, which is 130. In the process of creating the model, we can be divided into 4 parts: embedding layers, LSTM, dense, and DAM. Then we may get the following output. The idea of training model is to fit the input and output results. In the training process, we use the learning method of many bench, which is in a bench size of 128 and 5 epochs. At the same time, we design checkpoint to store higher precision test result in real time. Then we may get the training results. The main idea of our test is to substitute the data of X test into the created model, predict the emotions contained in the film review, compare the text results with Y test, and use the accuracy of the test result to evaluate the performance of the model. After that, we can get the test result. We could see the correct prediction, wrong prediction, and accuracy. Then, below the existing model, we input any film review according to the similar steps of establishing the model. Process the film review first, convert the film review information into digital information, and fill or cut review information to control the length. We can calculate the prediction probability and threshold. When the prediction probability is greater than 0.7, we judge the emotion as positive, otherwise the output is negative. When we enter film reviews as here, through calculation, we can get the prediction probability is 0.97, which is obviously greater than 0.7. So we can predict that the emotion of the result of this film review is positive. The procedure is as follows. Cui Jinkai will speak for the next part, which is the conclusion. Here is the process and here is the result of this.
In my part, I will discuss our summary. First of all, we choose to analyze and predict the model of the film reviews, and you can hear about the implementation in the part 3. In this project, we understand to use the LSTM as the core of the model, build a learning model with the help of TensorFlow or other tools, and successfully obtained the emotional analysis of the film reviews. Actually, we also encountered many difficulties in the process to come through this project, such as when we build the environment and install the relevant packages of the TensorFlow. We found some packages don't match our version of the TensorFlow, so we should try different versions to confirm whether we can meet our needs. On the other hand, after NTLK installation, we need additional download stop words to run the program correctly. In fact, we pre-process all data through test reduction or supplement, which will also lead to some problems, loss of information and interference with information production due to failing, but it's okay. This project had a wide range of application. We can predict the common modes in various environments through this mode, so as to obtain the evolution trend. In the future, we may improve our mode, such as change the mode size to improve the speed, or we may discuss more NLP mode and try to incorporate into our mode. In short, in the future, we may keep the existing function of the mode and improve the mode to make it perform better in emotion analysis. We may add more function to the mode. In this process, we will continue to learn relevant knowledge of NLP, which can also improve our skills, and it can let us know more NLP knowledge, which is very useful for our future. Thank you for listening.